All right, welcome back. Today we're going to talk about section 7.2, operations with matrices. So for day one, we are going to focus on addition and subtraction, and as well as scalar multiplication. In order to add or subtract matrices, they have to be the same order. If they are different sizes, you can't add or subtract. When you do scalar multiplication, you're just taking the entire matrix and you're going to multiply it by every number in the matrix by a number. So we'll go ahead and take a look at this here. For the next 3-4 slides, you're going to see the same 5 matrices. So at the top of this slide and the next few after that, you're going to see A, B, C, D, and E here, and they are going to remain the same throughout all these examples. You can see that A and B and C are all 2 by 2 matrices, and D and E are 2 by 3 matrices. So when we get into adding and subtracting, we can do any addition or subtraction with A, B, and C, and with D and E. However, we cannot add or subtract D and E from any of these top 3 because they're not the same order. All right, so we'll go ahead and get started. For our first example, we're just adding A and B, and when you add matrices, you kind of got to look at this as kind of being a grid or a map. So we have the number in row 1, column 1 here for A, and we are going to add that to the number in row 1, column 1 for B. Then we'll do the same thing for row 1, column 2, row 2, column 1, and row 2, column 2. So you can see that we add the numbers that are in the same location in each matrix. And when we do that, we get our result here. 1, 16, 11, and 6. Typically for matrices that are smaller than 3 by 3, we'll do this by hand. I'm going to post a calculator tutorial as well this week, but usually for a 2 by 2 matrix, we're not going to bust out the calculator for adding those. All right, so there's A and B, and again, we're going to use these same 5 matrices for these next few pages of notes. So as long as you have them down one time, you don't need to keep recopying them for each slide. All right, second example here. Let me slide this down a little bit. So now we have A minus C. So again, we start in that first row, first column, 4 minus 1, first row, second column, and then we have our second row values. And so again, here is our result, 3, negative 7, 2, negative 10. Our third example here, we actually end up with D and E. So just to give you an example with the 3 by 2. And so when we do that here again, you add the numbers that are in the first row, first column, first row, second column, first row, third column. Same thing for row 2. And here is our result. So again, for matrix addition or matrix subtraction, the size of the matrices, the order has to be the same. I can't take a 2 by 2 matrix and add that to a 4 by 1. Or I can't take a 5 by 3 and add that to a 2 by 4. In order to add or subtract, the matrices have to be the same order. All right, again, you can see we're dealing with A, B, C, D, and E. Again, that hasn't changed here on these slides. Again, just simple addition this time, so B plus C. So now I'm taking these 2 matrices, adding them together. Again, first row, first column, first row, second column. You see that right here. And then same thing with the second row and our result. Again, feel free to pause at any time if you need to, so you can write this stuff down. A minus B. So last slide we did A plus B. This time we did A minus B. So slightly different numbers here, but again, first row, first column, first row, second column, the numbers in second row, and then second row, second column. So you're always looking at the same number in the same spot. So when you add or subtract, you're taking the numbers that are in the same location in the matrix. All right, last one we did D minus E, so same idea, same numbers that we used before, only now we're subtracting. And again, here is our result. Again, feel free to pause if you need to write these down, or to go back if you need to. All right, next page, we're going to look at some scalar multiplication. And really, all you're doing with scalar multiplication, you're going to take whatever this number is, and you're going to multiply every number in the matrix by that number. So we took every number in matrix D and multiplied it by 5. And you can see our result here when we multiply every one of these 6 numbers by 5. For scalar, it can be any number. The only number it can't be is 0. You could see a fraction. It could be 1/2 D. It could be a negative, -3D. But typically, we'll use integers. Every once in a while, you'll see a decimal, but not often. All right, 3e. So again, we're going to take all the numbers in this matrix, multiply them all by 3, and here's our result. Again, it is intended to be that straightforward, so please don't break rule 1 on this. You're just taking the numbers in the matrix and multiplying it by this scalar factor here, by whatever number that they put out in front. The last one here, I just kind of combined these two. So we already have 5D. We did that work right there. And we did 3E, which is this work right here. And now we're just going to add them together. So again, we're going to take the number in the same location. So first row, first column, 5 plus 36. First row, middle column, -35 plus 18. First row, third column, 0 plus -6. And then we are going to do the same thing for the second row. 25 plus 21, 10 plus -15, 15 plus 12. And when we do that, you can see our answer there. So again, we just took the answers from our previous work here, and we added these two together to get our final answer. Okay, again, you can see we're using the same 5 matrices, so A, B, C, D, and E. We haven't changed that, done anything different with those. My work here is slightly different. Now I combined the work for both of these into one problem. So I took matrix A here and I multiplied all of those numbers by 2. That's what you see here. So this is really 2A. And then I took matrix B and multiplied it by 6, and that's what you see here. And now I will add these together. So 8 plus -18 is -10. 14 plus 54 is 68. -2 plus 72 is 70. 0 plus 36 for 36. So you can combine your steps to limit the work a little bit. That's more than okay. Similar idea here. Give me 1 second here to eliminate this shade here. Sorry about that. There we go. So 3D and 2E. So I'm going to take everything in this matrix times 3. That's what you see right here. And everything in matrix E. Now be careful with this. I know it's -2. So you can do this one of 2 ways. You could put a plus here and multiply all of these by -2. What I did is I just left the minus and I multiplied everything here by +2. So really I did positive 3D minus positive 2E. But if you want, you can make this a plus and multiply all these by -2. We'll get to the same answer. So again, after we multiply, 3 minus 24, -21 minus 12, 0 minus 4. Excuse me, 0 minus -4, so it's positive. 15 minus 14, 6 minus -10, and 9 minus 8 for 1. So that is our addition and subtraction and scalar multiplication. And I've got 2 more things, 2 more examples to show you here for this first day of 7-2. Okay, so here you can see we have 2 matrices. And the first one is set equal to the second one. If that's the case, then each one of these numbers in their location has to equal the number over here. So this one's pretty straightforward. If this has to be x and this has to be 21, then we know x has to equal 21. And if this is y, y has to equal negative 15. If it doesn't, then these two matrices aren't equal. And again, you can see it's kind of hiding there. Don't break rule number 1. So this problem here is designed to be that simple. So if this matrix equals this one, which is what it says, then x has to be 21, y has to be negative 15. Our last example is going to be similar to this, just a little bit more complicated, but same idea. Okay, so now you see first matrix equal to the second one. Instead of just x or y, now we have an algebraic expression. So 3x plus 3 is going to equal 21, and 2y plus 1 is going to equal negative 15. And now I just have two linear equations. I'm going to solve this one for x, so subtract 3 over, divide, and over here subtract 1 and divide by 2. So again, we can solve for x and y here. It's a couple more steps in the previous slide, but same idea. So that will conclude our notes for day 1 of 7.2. So I should have everything you need to do that first worksheet, and we'll see you in a couple days. All right, thanks.